Hi, so today we're going to be going over a machine that has no backlight on the screen. So the first thing that you're going to have to do with these issues is try to determine whether you have no backlight or no image, and then you also have to determine the difference between no image and no brain. So when a lot of people say no image, they mean no brain, which is that the computer doesn't have V-core. So when you first turn the machine on, it should go dong. It should have a nice long chime, or as Sonny would say, it should have a nice long dong. Once you've confirmed that the computer has chimed, then you should look for an image. Then if you see an image, then and only then can you look for a backlight. You're not going to get a picture on the screen if the CPU is not turning on. The same way you're not going to get a backlight on the screen if you're not going to get a backlight on the screen if the screen itself is not turning on. So this is a pretty smart machine, and it is going to try to tell if the screen is turning on before it turns on the backlight, because if there's no power going to the screen, then there's no need for that. So let's take a look. Now, the first thing I like to do in a case of no backlight is I like to check the circuit all the way at the output. So whenever you're doing stuff like this, try to save time in measuring as much as you can. That is key. So what I'm going to do is I'm going to check the voltage at output. So when I check the voltage at output, meaning black probe on ground and red probe at output, I get output of 0 volts. Now, at the beginning of the circuit, I get 12.13 volts, which means there is voltage in the beginning, but there's not voltage at the end. So that means that we are going to work our way through. Now, let's just take a look over here on the screen and try to get an idea of what's going on. So if I were to go over here and just look for where backlight output is, you're going to see that this is a DC to DC boost circuit. And the idea behind how the DC to DC boost circuit works, it seems complicated, but it's actually quite simple. So we're going to have our 12 volts come in over here. This is our 12 volts coming in through a backlight fuse. And then it's going to come down here and go through this inductor. Right after this inductor, there's a line between here and this chip. And over here it says SW, which stands for switch. This chip is going to switch this voltage, this 12 volts coming through the circuit, from here to ground really, really quickly. Now, this is going to be kind of like stopping short in a car. When you stop short in a car, even if you were only moving at 15 miles an hour, when you hit the brakes as hard as you can, so you stop immediately, you're going to jolt forward. And you're going to jolt forward just a little bit faster than that 15 miles an hour. The same way that when you stop short over here, you're going to go to 0 volts, but once it's no longer shorted to ground, once this switch goes back to, just not being switched to ground, this is not going to just let out 12 volts, because what you've done is you've kind of asked the supply power very, very fast, and this reacts very, very slow. So it's going to try to send all that power out. So instead of sending out 12 volts, it's going to send out whatever was stored in this coil. So this hump is going to go, and then you're going to have 15. And this hump is not going to have any power, then you're going to have 18. And this hump is not going to have any power, then you're going to have 21, and this hump is not going to have any power, and then you're going to have 27 or something like that. So this is going to continuously happen over here, and that's going to raise the voltage. Now, once the voltage is raised from that stopping short, you're going to have this diode here. Now, the idea here is that the diode is only going to let the power pass in one direction. So instead of going forward and backward, it can only go forwards. It can only go from left to right. These capacitors over here are going to be used as a battery. The capacitor is going to store the power. Now, the issue here is that if we have the capacitors store the electricity, and then this over here switches to ground, then all the power that was stored over here is just going to go right back here and go to ground, which is why we have the diode. The diode is going to keep the voltage that's stored in the capacitor from going to ground when this decides to switch. And if you want to see what this looks like, so this over here is going to be what it looks like when it's just your standard 8 volts before the inductor. Now when you start, this is going to be the 8 volts after it, starting over here. Now when you short it to ground, it's going to go to 0. That's your stopping short. But then after you stop short, this is you getting shot forward in the car. And now you're all the way up to 27 volts. So that's how the DC to DC to boost circuit is going to work. And right after those smoothing capacitors, it's going to have a nice, smooth 27 volts. Because keep in mind, when the voltage is up, that gets stored. But when it goes down, the capacitors are then going to fill that in. And that is how this circuit is working. So what we want to do here is we want to figure out what point here is the break. So I measured over here and I get 0. That means a break in the line. I measured here, I get 12. So now I'm going to want to measure one step after. So after the fuse over here, after F9700, we're going to have this transistor. So the first thing we're going to want to do is this transistor opening? So I'm going to want to measure PP bus SW LCD bicklet per. So I'm going to go over here to the board, and I'm going to open up the right board view because this is not the right board view that I have on the screen over here. So we're going to open up the right board view and then just see everywhere in the board that signal shows up. And hopefully there's a place that it shows up on the top. It would be really cool if I could fix this board without taking it out of the computer, but who am I kidding? That is luck that I simply never have. So we're going to measure right over here on this area, and right over here we should see if we have voltage. So I am going to just put the camera back on so you can barely see the multimeter, and we're going to measure voltage at that point. Now one thing that I do want to do here is just click the trackpad a little bit, click and just put the brightness all the way up on the keyboard. Do keep in mind that if you keep the machine on the desk, that eventually the backlight is going to go off, simply to conserve energy. So once the computer is told to turn the backlight off to conserve energy, obviously you're not going to measure anything because it's not being told to turn the light on. So you do have to keep in mind that you should press it every now and then. It would be really silly to keep it on while doing all these measurements. Now I have 0.001. 0.001 is not a voltage I can do anything with. So right now at this point I can go ahead and just turn the machine off, and we're going to take it out because all the important things that I want to measure are on the bottom. Now if we go back to the screen capture software over here, you're going to see on this area, this is a P-channel Mosfet. And the idea behind a P-channel Mosfet, when it's used the way it's used in this particular circuit, is that it's only going to open when the voltage on the gate is lower than the voltage at the source. Now unfortunately this is not labeled because when they were making the schematic they decided not to label it. There are some that are labeled with the gate, the source, and the drain. This one is not labeled, but you can easily look up what each pin is if you simply Google this over here. This is the model of that particular transistor, and you will be able to find the data sheet which will tell you which pin is which. So on this is the source, which is what's coming into it. This is the drain going out of it, and this is the gate. Now over here we have 12 volts on our source, which means that if we have 12 volts on our gate, then that is not going to be told to open. However, if we get a lower voltage in the gate, like 5 or 6 or 7, then this transistor over here is going to open. So what we're going to do is we're going to try to ascertain whether the transistor itself is bad or if the transistor is not being told to open. Remember, a P-channel MOSFET, like this MOSFET on the screen, is going to open when the voltage on the gate is lower than the voltage on the source. So if I have 12 volts on the source and 5 volts on the gate and it's not opening, that means that there's something wrong over here. However, if I have 12 volts on the gate and 12 volts on the source and it's not opening, I cannot blame the transistor because it's simply doing its job. Another thing I'm going to notice as I take the machine out of the computer is that I was this complete idiot, and that I didn't check the voltage after the fuse, because it's very simple that the fuse itself could have simply blown, and that could be why nothing is working. So I'm going to check that right now before I do all this crap, because that would be really stupid if I didn't check the fuse. So if we check the fuse, we're going to put the multimeter here in a continuity mode, which is going to give us a nice 0 if we connect the two probes together, and we're going to check the backlight fuse before we go further. So when I check the backlight fuse, you'll see here that I get 0, which means that the fuse is good. Whew. That would have made me look pretty stupid if I were doing all this work when all I needed to do was replace a fuse. But life is not usually that easy. It's not going to be just a fuse. Most of the machines where it's just a backlight fuse have been filtered through, since I've done 200 or 300 instructional videos on how to fix your own machine. That was the death sentence of easy or simple repairs. Those are, we don't get any of those anymore. It's been a while since I remember just getting a just backlight fuse repair. Those don't happen anymore. Anyway, let's take the board out. We're going to take a little bit of a look at what it looks like on the other side. Now, do keep in mind that in order for the backlight to actually put a backlight circuit to work, it does have to detect a screen, as I said before, which means I'm going to have to find some convoluted way where we plug the screen in and then do our measurements on the other side of the board. So I'm going to plug in the screen over here. And I'm not going to attach the hard drive because I don't want the machine to go to sleep. I don't want the screen to turn off. And if there is no drive plugged in, there is no operating system, it's going to stay on in EFI mode and just never get to a point where it's going to turn the screen off, which is a good thing here. So we're just going to do this. I'm going to try to plug this in. I'm going to try to flip it over. And after I flip it over with the screen plugged in, I'm going to hope that I don't short anything out electrically that's going to light me on fire. And if I manage to do that, I'll be a happy guy. So it looks like I've managed to not short anything out, and now we're going to go over and check the gate of this transistor. So remember, the gate on this transistor needs to be a lower voltage than the source of it. So we're going to check pin 4 and pin 3 of Q9706. We're going to look over here for Q9706, and let's see where we are. So we're going to, oh, rotating is so nice. There's no errors in this new board view software. It's amazing, amazing software. Thank you so much to the person who made this. Absolutely amazing stuff. And a lot of people had contacted me saying, you know, do you think there's a market for this? And I always said no, not because I didn't want it, but just because admittedly the other software sucks, but it's not one of those things where like I'd pay $100 for a new. I mean, I know that coding is very, very difficult. I know that making this software is difficult. I respect that. I don't want it for free. I'm not going to demand somebody make it for, well, I do want it for free. I'm not going to demand somebody make it for free. But if I can get it for free, but if, you know, if I can't get it for free, then I'll just keep using that T-Link shit. But it's really nice that T-Link doesn't exist anymore. So if we look over here, I get 12.51 volts on the source. And let's just see if I can get this so that you can see what the board looks like in that area. And it seems like the microscope camera is positive. Is the microscope camera fucked? Or yeah, it does look like we're stuck on an old image there. So the microscope camera is fucked. Let's see if I do this, if we can get the microscope camera back and working. I unplugged it, I plugged it back in, and yeah, that's pretty fucked. Let's restart Open Broadcaster and see if it works. Okay, and we're back. Oh, and let's see, is it doing a weaving thing? No, it looks good. Yeah, I've been having some issues lately with this, and I think a lot of my issues have to do with the fact that I'm using two capture cards from different brands, and instead of using a single card that has dual HDMI input, I'm using a StarTech capture card and a Blackmagic. So first I got the Blackmagic, and I realized that the Blackmagic card with one HDMI input, check this out, check this out, check this. This is one of those reasons where I would just never endorse a Blackmagic product for anything, regardless of all the good press they get. So they have an HDMI capture card, right? That HDMI capture card works with my camcorder. Every now and then, I'll start it up, and the software will not see the input. Their software won't see it. My software won't see it. I'll go in and I'll select the exact 1080p, 59.94 progressive, all that stuff, and it just won't see anything. And by that's another thing. It won't auto-detect. Like if I say 720p, 59.94p, it will not work with this camera. I have to select the exact output of the camera. And if you don't know it, you just have to scroll through each one and keep going back and forth until you get a picture. So, but even if I do all of that, that's not standard to virtually any other capture hardware, so it's something that is going to confuse you at first until you read through 13 pages of a forum thread. But it works with the camcorder. It works with my camera. It doesn't work with the microscope camera. And when I contacted Blackmagic about this, because some of these, you know, if you look up their website, their stuff isn't exactly cheap. Their reason for the microscope camera not working is, check this. Oh, this is designed for broadcast hardware, not medical hardware. This is considered a medical device, so that's not going to be compatible with our products. And it's like, are you fucking kidding me? I mean, it's an HDMI capture hard. Like, it shouldn't matter if it's a broadcast device, a medical device, a pornographic device. If I plug an HDMI connector, if I plug an HDMI cable for something that has an HDMI out into the fucking capture card that I paid professional money for, it should just capture video. So I got the Blackmagic, and that's used for the camcorder, but then I had to figure out that I can't use a second Blackmagic for the microscope. So I bought a StarTech card, which it's kind of prosumer. I like StarTech stuff, but it's kind of prosumer in the features. And I don't know if it's just that each individual card doesn't work well with Windows 10 or Windows 8.1, or if it's the fact that I have both cards working and capturing at the same time. It could be a number of different things, and I'm sure I'll have a lot of stuff in the comments from people who've never tried to use either one of these cards telling me how to fix it, but I digress. I've tried this at this computer, I've tried this on the home computer, and it's the same thing. I think it's the fact that the right thing to do is to have one card that has two HDMI inputs that's made for dual capture. And I'm trying to use two different cards with two different drivers at the same time to capture two different very high bitrate streams. That's occasionally doing those fuck-ups where I'll click and it'll be stuck on the last image that it saw, or it won't capture anything at all until I reboot. Which is kind of fucking annoying in the middle of the video. But the StarTech thing, I'm okay with that. But like the black magic shit, you're telling me that this microscope camera, this is not cheap. This is an optics cam, OCS, HDMI, NH1080. This thing was like $700 or $800 when I bought it. You're saying that it's not compatible with this, which it's a basic 1080p, 60 frame per second output. I can output this to a $90 Acer monitor and it works. I can output this to a piece of shit $150 Magewell thing and it works. I can output that to any TV, anything, and it works. But it doesn't work on a Blackmagic card. Are you fucking kidding me? Like, can you list with the Blackmagic product, hi, yes, this is a professional video product. However, there are a great number of devices with HDMI outputs that will not work with it, and we will not help you. Like, anyway. Rant over. Now we're going to go back to fixing this board. Let me just open up the PDF that had the schematic on it so we can go back to where we left off before dealing with technical difficulties. And that's one of those things when you do a project like this. Like when I first posted saying, this is what I want to do. These are the type of videos I want to do. Here's the setup that I want. I don't want to have to do audio afterwards. I want the audio in sync with the video. I want to be able to switch back and forth between microscope view. I don't want to have like a camera that looks about the side or zooms in on the board. I want it to see exactly what's seen in the microscope. I want it to be high quality, not this 5 frame per second mantis bullshit. It's real, and I want to be able to record all of it in real time. It's really hard when you're like trying to do something that nobody else has tried to do before to get it done. That's what I've noticed. It's like, you know, a lot of experimenting, a lot of buying stuff that doesn't work or that people don't know if it'll work for an application. So, I mean, I'm happy with the fact that I can do the videos the way that I can, but it would be nice if I didn't have to worry about this every now and then. This morning's video, pretty decent video, just randomly screwed up in the middle of it just because of this whole dual capture thing. Sometimes it works, sometimes it doesn't. And, you know, if somebody else is fixing it, they're not going to see if they're not operating the camera. And just, you know, just lame. Anyway. So let's just re-explain what we were looking at here before I went off on my complete tangent on video capture. So we are getting voltage over here. We're getting 12. Now on here, on the gate, I want to get less voltage. So we're going to check what pin 3 is giving me right now. So pin 3 is going to be over there. So I'm going to switch back over to the microscope view. We are going to measure pin 3, and pin 3 is getting me 12.41. So this means I cannot blame the transistor. The transistor is doing its job. The transistor is not opening because it is simply not being told to open. The voltage in the gate has to be lower than the voltage in the source in order for the transistor to open. So let's take a look in the schematic and try to get a little bit of an idea of why this happened. And where you go? Let's see. So yeah, we're on the schematic. So the way this works is that this resistor over here is going to take the 12 volts from the source and place it on the gate. That's going to mean that this never opens because the voltage in the gate is going to be the same as the voltage on the source. However, this resistor over here that goes to ground is then going to lower that. This resistor turns this into a voltage divider. And if you don't know what a voltage divider is, you should Google what a voltage divider is. It's a very simple little circuit that's going to take a higher voltage and turn it into a lower voltage. So some voltage is going to go here, but then by putting a resistor to ground, and this resistor over here is a much lower resistance than the top one, that means that a lot of the current is going to flow to ground, but not all of it, which is then going to lower the voltage. So again, if I simply put a resistor to ground over here, if I just take this resistor from here and put it to ground, it's not going to lower the voltage because this has a lot of capability to deliver current. However, when I put this little 301 kilo ohm resistor here, now I've very much so limited its ability to deliver anything. So when I put the second resistor to ground, now that's just pounding it into the floor and beating the voltage down. However, this is not going to work if this doesn't go to ground. What's keeping this bottom resistor from going to ground? Well, these two transistors. These two transistors are the opposite of this type. This up here is a P channel, and these over here are N channels, meaning that the voltage in the gate has to be equal or higher than the voltage in the source in order for it to open. Now, if we look at this really carefully, you'll see that the source over here is ground, and the source over here is going to be probably 0 as well. So here, any voltage on LCD backlight enabled and any voltage in backlight platform reset is going to make these open. So let's try to figure out if these two transistors are opening and if they're being told to open. So let's check out LCD backlight enable and backlight platform reset. So we're going to check out pins 5 and pins 2 of Q9707. So let's see. Q9707 is this thing right over here, so we're going to check pins 2 and pin 5. So let's go over into the microscope camera and check out pins 2 and pin 5, see what voltage we get, and see what conclusions we can draw. So I'm going to measure voltage on pin 2, and I get 3.2. And I'm going to measure the voltage over here, and I get 3.2. All right, now we have, so this transistor is being told to open, and this transistor is being told to open. However, the voltage over here is still 12, so it's not being told to go to ground. Now we have a couple of different possibilities over here. The first possibility is that this resistor is blown, this resistor is dead, so it's not going to do any voltage dividing. The second is that this set of transistors are dead, so they're not going to send it to ground, they're not doing their job. The third possibility is that this transistor over here could actually have a short between pin 4 and pin 3, so it's constantly sending all of it, so it's bypassing this resistor. Instead of sending a little bit over here, it's sending all of it over here. The fourth thing that could be bad is this capacitor. If this capacitor is bad, again, this 301 kilo ohm resistor is sitting between here and here, but if this capacitor dies and it becomes a wire, if this transistor dies and this link breaks and it just shorts, then this resistor is just erased from the equation. So one way to figure out what it is. So what we're going to do is we're going to measure the resistance between R9788. Now remember, we're not just measuring the resistance of this resistor, we're measuring this pathway. So you have a pathway from here to here, but we're also measuring the pathway between here and here, and here and here. So let's check R9788. We're going to measure R9788 over here, and we're going to see what it is that we get. So R9788 is going to be this one. You didn't see any of that. Oh, man. Okay, re-explaining time. I'm sorry about that. So the idea here is that if we have 3 volts here and 3 volts here, that means that these transistors are being told to open. But the voltage over here is not being dropped. The voltage over here not being dropped could be because of a couple of things. Either this is not having a path to ground, or there is a path to ground, but the capacitor shorted, or the transistor shorted over here, so that even though there's a path to ground, this 147 kilo ohm path to ground over here, it's not dropping anything because the 12 volt rail is shorted to this. So remember, this resistor is going to be what limits the current. So the current being limited over here is what's going to allow this resistor to then drop the voltage. However, if there's no current limiting, if the entire ability of the circuit to provide voltage is present over here, it's not going to do much. It's not going to actually drop anything. Remember, a voltage divider requires the top resistor and the bottom resistor. If we take away the top resistor and just replace it with a wire, it's not going to drop shit. So if this is shorted or this is shorted, we get nowhere. Now, that being said, let's measure that resistor and see what we figure out. So the resistor that I'm looking to measure over here is going to be, let's see, R9788, which is going to be the one that's covered in some nasty looking shit over here, some pubes. So let's just dig this out, and now that resistor is supposed to be 301 kilo ohms, and when I measure that resistor, I get 301 kilo ohms. So that is doing its job. All right. Now let's check out. Oh, so let's see. So this is 301 kilo ohms over here, right? So that means that this cap isn't shorted. If this capacitor were shorted, then this would measure lower because they're in the same path. They're connected, literally in the same path. They're connected. So if I measure this, I'm technically also adding this as well. And I'm adding 4 and 3. So I can rule out Q9706 being bad, I can rule out C9782, and I could rule out R9788. Now let's check R9789. Let's see what R9789 is going to get me. So R9789, where are you actually? Where the hell? Oh, let's see. R9789. You're right over here. So let's measure this one and see what we get. So when I measure this one over here, I get 147 kilo ohms. Alright, so now, this is genuinely interesting. I'm gonna reconnect the power to it and just see if I'm getting trolled. So this is being told to open. And we're getting a light on the screen that we weren't getting before. So check it out. What, you don't believe me? Today is not a good day for repair. So remember that remember how I was getting 12 volts On the gate of Q9706, we're now getting 4.3, and it's turning on. What did I do? I don't fucking know. No, really, what did I do? Ah, aha! Yes, the pubes are hiding the liquid. Tell me this went black and white again. Are you kidding? It did. You piece of fucking shit, Cam. What the... I need to get a proper HDMI setup. This is bullshit. This is bullshit. Look at it. You can see blue and yellow from the last thing on here. All right, and we're back. And now you'll be able to see everything in full colors. I really do need to get a better HDMI capture setup. See how color makes such a big difference? Even though I did a little bit of scraping over there, you can still see that water made its way here. And I am going to try and get myself some better HDMI capture. I just got lighting from my apartment too. See, you can see there's some blue. This area over here has already been scraped. And this area here. So we're just going to go ahead and touch up this area a little bit. And then put it through the ultrasonic cleaning for a nice cleaning. And after that, we should be set. Now, one thing that is... Oh. Actually, you know, let's just get rid of that first. I finally got... I actually went to the basement to get some stuff the other day, and I realized that back from when I had the supply business... Oh, that resistor looks like shit. That's got to go. Anyway, back when I had the supply business, I was taking pictures of the screens and product photos. We went to B&H. I got a camera which somebody stole 4 years ago. That's the story in and of itself. And we also got these lights. Now the lights are, the bulbs themselves have been sodomized and destroyed because they got beat and they've been thrown in a basement on top of boxes and all sorts of other crap. So the fluorescent bulbs in there are fucked. However, that's the thing. I was being cheap. I didn't want to buy new fixtures and new lights and all that. But if I already have working fixtures, I already have like the fixture and I have 2 fixtures that will hold 3 bulbs each and has like the diffusing thingy. Well, not really. It has the thing to hold the light and everything. I might as well buy the bulbs. So I bought 6 LED bulbs on Amazon, some studio lighting LED bulbs to plug in that are going to look all nice and stuff. So I'm going to have that for the apartment. I just spent, because as much as I am cheap, also when it comes to, that's not good. If I already have something, I feel this compulsion to finish the set. So I already have that. I can't let it go to waste. Just some gentle scraping, and bam. The resistors in that voltage divider just don't look very good, so we're just going to take those resistors and that capacitor and just goodbye. Even though it works now, and even though I may have scratched away whatever was causing it to not work, no, we're not leaving that on the board. So let's just go ahead and remove that junk. Yeah, it's on the list. I gotta get some better HDMI capture hardware. Because someday I'm gonna do a video, and I'm not gonna be paying attention to it because I'm watching the board I'm fixing, and it's going to work, and it's gonna be an amazing video with an amazing new revelation, and some really cool dialogue, and I'm not gonna be able to post it because of the fucking capture hardware. So a good dual HDMI solution. Dual that can capture, that's made for it. That's actually designed to have both used at the same time. None of this, oh, well, it may work, but we don't support it. No, fuck that. I gotta find something that works, that is supported that way. But I'm gonna probably wind up paying ridiculous amounts of money. I saw something like that. It was something like that. And the reason I didn't go for it is it didn't work in Linux, and back at that time I was using Linux. And also, it was $1,800 plus tax and oh my god. Plus tax and all that stuff, and I was just like, hell no, 1,800. Now that's like a drop in the bucket with how much I've spent on everything else. But the thing is, I forgot the damn name of the card. Oh, and it's got to work with Open Broadcaster. That is an absolute must. If it doesn't work with This is how I'm used to capturing things. Open Broadcaster makes my life easy. It has to either be something that's compatible with Open Broadcaster, or it must come with its own software that is better. And it can't be any of this shit where they don't let you adjust the audio type that you use or the codec you use, where you're stuck using their crappy-ass codec. I like Open Broadcaster. I can choose X264. I can choose my parameters for libx264. I can choose ProRes, which honestly is really is pretty good to work with and edit. I can choose raw video if I want. I can choose 422. I can choose 44. Actually, I can choose 444. I can choose 420, and that's free. So I'm spoiled. I know that I got options, and I do want to keep these videos looking good. I do want people to be able to watch and really get what I'm doing. So I usually record at a really ridiculously high bit rate with ProRes. I export it usually to 60 to 85 megabit per second. H.264 file with FLAC audio. I usually record in WAVE. And then after that's done, I upload it to YouTube. I give YouTube a really high bit rate file. The thing is, I know that YouTube is going to take whatever I upload and just destroy it. So I want to give YouTube the best possible copy. And I also want to keep a good copy for archival purposes for myself. What's up?
Just to confirm, 2011 Air, X on the battery, most likely SLC, right?
100%, 110%?
110%.
Did you try another battery already?
Yeah, I did.
All right. So now we're just going to flow that into place. Looks like a nice little neighborhood. And we're going to just double check and confirm that our work worked. First, we're going to turn off all this loud stuff because it does eat your brain. Inhaling flux all day eats your brain, but listening to that eats your brain just like one step lower. So I'm just going to turn it on, see what I get on the screen, and we'll be happy from there. Now, this still is going to have to go through an ultrasonic cleaning process and also get tested because it did have a liquid spill that, of course, nobody ever admits to. But it did have a spill. And as you can see, we get a light on the screen, which means that we have fixed our problem. So the corrosion was primarily in the... Oh, I rebooted, so my schematic closed. The corrosion was primarily in the... Sumatra remembers where I left off. What an amazing PDF reader. Over here. Over this, and over this. And it was most likely shorting this to that. But as soon as I just touched it with the multimeter, the corrosion moved away. We did a little bit of flux and cleaning. We replaced these components as preventative maintenance, and we will then be ultrasonicking the board to fix any further problems. So that's it. We fixed no backlight, and as always, I hope you learned something, and I'm going to go off and do some research on dual HDMI capture hardware that isn't shit. And that's it for today.